Dear learners, welcome to fourth session of fourth week of Managing Industry 4.0 course. I am sure that you must be enjoying and learning the concept of Industry 4.0 and their applications. In today's session, I like to cover a very important technology, digital twin, which is being widely used now since last couple of years. Once industry realized the importance of digital twin for various kind of applications. Digital twin is not a new technology, it's quite old technology, but it is spread and its popularity has increased in last couple of years, I'll say 6 to 7 years. The first digital twin successful application was done by NASA to monitor and to govern the performance of spacecraft. So with that context, I like to start this session. Digital twin is little different from other technologies. Once you start learning that, you also realize. So in this session, I want to describe or I want to discuss the concept of digital twin. When we will start next week our sessions on smart manufacturing or smart factory, we will further study the application of digital twin in the industry. But in this session also, I am discussing quite a few examples of industry. For explaining the digital twin concept, today I am taking the help of a live digital twin which is very much used actively globally for our health purpose, so that learners can understand, contextualize how the digital twin work. So I thought it will be a fitting combination. After explaining the basics of digital twin, I switch over and use a live example which will directly connect you the technology and our health. So let us now start learning. What is a digital twin? You are seeing here two pictures. One is the a picture of physical object, and another is the picture of replica of this physical object in a computer system. Though I have made the shape similar, but it doesn't mean in the computer system also it will be same shape. But how so? Whatsoever, suppose we have a 3D view of this physical object in computer system, and we try to capture the functioning, the parameters, right from the design, fitting, assembling and commissioning, and afterwards using of this equipment, what kind of data it is generating, then it will become a digital replica. We call it digital replica. So a digital twin is a virtual representation of a physical object or system. This is a physical object or system. System may be a software also, that uses real-time data to accurately reflect its real-world counterpart behavior. We will be studying this in little detail. Performance and conditions. Real-world counterparts behavior, performance and conditions. Digital twins enable continuous monitoring, simulation, analysis of an object, product or systems over the course of life cycle from design, production to maintenance and decommissioning. So, digital twin play a very important role today in industry. Basically that when we say that is a digital replica of a physical object. This physical object may be anything. This physical object may be aircraft, the physical object may be a city, physical object may be full factory, or whatever is there in the factory, it can be a physical object or individual equipments. So, digital twin provide very great facility to right from design, production and to maintenance and decommissioning. Decommissioning means when the life cycle of this equipment or this object is getting finished. I have kept here a link YouTube video which is designed and developed by IBM. You can take advantage of this 6 minutes video and try to understand what this speaker says about digital twin. Now, if you see this picture, we are seeing here one side the physical object and other side the digital. So, if we consider this as a machine, this is actuator. Machine is having actuators. We call them sensors in our language, sensors which we have learned when we discussed IoT and edge devices. So, sensors and actuators are responsible for capturing the data data every moment, every millisecond from this physical object. And it is being captured, it create and communicate to the computer system which will start functioning as a digital twin. All data will come over here, and then computer system is having various other facilities like analysis and so many other facilities are there which we are going to study now. So, whatever is happening here, whatever data is being generated in this physical object and the kind of thing we want to monitor, but data pertaining to those functions is being sent or is being captured in the computer system, and then digital twin the structure start capturing this and then is being used in this system for giving various kind of outcomes, outputs and decisions which we will learn in a moment's time. This is another extended picture of the previous picture that physical and then how it is getting replica in the computer system which we call a digital twin. So, if you see on the down below this you will find quite a few computer systems, IT systems like ERP systems, MES, CAD module. So, what does that mean that when the data comes from this physical object, digital twin directly is integrated with all these kind of system which can give to digital twin the meaningful insight, meaningful data, so that it can work and it can deliver the desired outcomes which are expected from the digital twin. We like to learn this with the help of one live example which I am going to share in a few after one or two slides. So, just wait for till that moment. So, basically if you see the digital twin is integrated with lot number of the backend system also, and it is being data ingestion is happening from these systems and the digital twin systems. Basically whatever data, whatever information digital twin like to have, it is available on the backend system, so that digital twin can do the desired function. That is what is important to understand that. Digital twin refers to a this is another one should not confuse digital twin with computer-aided design. Computer-aided design was basically also an digital representation of any object in a computer system, But no, it was a passive system. No, it was not an active system. It can't give you any decisions. It cannot be used just monitoring for operation like function like monitoring kind of thing. How the machine is functioning, how the plant is functioning. Where the digital twin is a very active computer system. No, this slide. Key component of digital twin include physical object, which we have already discussed, virtual object, and data sources, which may be multiple sources like IoT devices, edge devices, or some other systems which we have already shown, that ERP and all those. Then data pipeline that transmits sensors data to virtual model. That is, the virtual model is on the computer, which keeping it synchronized with its associated physical assets in real-time basis. The very important is the real-time basis. And feedback loop. This we have to understand very precisely, that what is the significance of this feedback loop. If you go back to the previous picture, there is a feedback loop over here. Whatever data is being sent over here, action is being taken, it's being processed by the computer system. But once it is processed, action has to be performed on the physical object. So this is called the feedback loop. Once we get the feedback, means the data is being fed over here, and then whatever desired action is required or no action is required, it is being operated on this physical objects. So feedback loop can be understood by this simple operation. And then there is an analytic engine, which is a part of your computer system, analytic engine. And in most of the cases of digital twin, we have dashboards, which keep looking on the dashboard. One can know what is happening in the physical object, what is the status of the physical object, so that if there is any alert, so physical visual interfaces, sometime even the dashboards, multiple dashboards are being used for multiple kind of views, so dashboard is also part of the outcome which we like to see on the computer system or digital twin system. So these are the 6 or 7 key components. There are many components, but these are 6 or 7 key components which should be considered for building a digital twin. Now I like to come to a very interesting live example, so that the concept of digital twin will be clear to all of you. So here I am using the one application is called Twin Health. You can type twinhealth.com. This is one company which has developed quite a innovative solution for basically for monitoring and controlling type 2 diabetes, type 2 diabetes plus some other symptoms also. So twin focus on treating the root cause and helping heal your metabolism. This is the slide which I have taken the permission from the company who is known to me, and then I like to explain the function of digital twin with this live example. You can see that if we in fact what they have told me, there this cloud system is working in US, and this is the effort of many scientists which they have developed health replica of human metabolism on the computer. It has millions of parameters. Which has been captured. And some AI system is working behind this system. So this is a picture shows that the kind of health parameters, health variables, are the part of the data system, or data lake, whatever you like to call it. Now to understand this, one by one, this digital twin, these two kind of technologies are the fundamental technologies, though there are some other technologies like cloud computing, edge computing, etc. But they are the two fundamental technologies. Like we are seeing here a car, and this replica of this car is being made on the computer, the digital twin. Similarly, this is the human body, and if with the help of some sensor, if we are able to capture the what is happening in the human body, what is the glucose level, what is the blood pressure, what is the energy level, what kind of how much a person has slept in the last night, how many steps he or she has walked, So all this data can be captured with the help of these kind of sensors, which I am wearing one of the sensors like digital watch, So, but they have used a different kind of customized sensor, which is being when the patient or whosoever would like to use their system as to wear on their body, So here, IoT, with the help of IoT, kind of is connected with your the system, whatever they gave as a gadget, I will call it, is being connected to your smartphone, and then data is being transmitted to their cloud system, and then a bunch of or a group of AI analytics system come into picture. So let us see little more elaborated picture. They call it an AI digital twin system, and they have given the name healthier metabolism. Why they call it healthier metabolism? Just a minute, just wait for a few minutes. Twin precision treatment powered by whole body digital twin. So now question comes that if we want to give a treatment to a patient or a person, we should know what is happening in his or her body. And especially we should try to monitor certain parameters. The parameters which causes the symptoms like diabetes type 2. The parameters which causes the symptoms like diabetes type 2. So if we are able to capture those parameters time to time, then a decision can be arrived by the system that which is causing the disturbance in the body of the human or body of the target person. So that is what is the theory I have understood, which they apply that. You see that they have divided these parameters in some categories, like nutrition, what kind of nutrition a person has taken, what kind of activity whole day he or she has done, 24 hours, how much sleep they have taken, what kind of breathing pattern is there, what kind of stress is causing them this problem, and what kind of medication, medicines they are taking. So all these parameters, are the one of the reference parameters which they like to have for providing further diagnosis to the problem of the said person. So any problem they relate with the two combination of biology problem and behavior problem. Biology problem is your diabetes, and it is being caused to some extent as per their studies by the behavior, our lifestyle, our kind of nutrition we are taking, and if we are under stress. So these kind of parameters are important to be analyzed for any person as per their approach. So how to get them? So this is their mechanism. As I said, they have a bunch, 3-4 sensors, which are being applied on the body of a person who he or she is taking this kind of treatment. This data is being captured for quite some time. Say at least for 6 weeks, they capture the data, try to understand the metabolism of this person, and then the system start giving the advice. So you can see that once system get confident in after learning the kind of medicine, kind of nutrition, kind of the lifestyle this person is living, and the sleep this person is having, whatever all the behavior and biology which we have discussed earlier. And once system know about that, then this is, as per their algorithm, system which call them AI algorithm, system start giving some advice about the nutrition, what kind the medicine, whether they should decrease or increase that their medicine doses, what kind of activity they should do, whether they are not doing physical activity, they should do physical activity to have better balanced metabolism, whether they should. So like that, breathing also very important aspect. These kind of recommendations start floating on the screen of the person who is taking who is using this system, Twin Health. This is another picture. So kindly excuse me, I am not going to go through each and every picture, but in this deck, which has been sent by them only, I included all PPTs. You can go through them. This is quite informative, self-explanatory, and my purpose was to use this example to explain you that how the digital twin, especially in case of health, monitoring our health, and here, when we say health is a type 2 diabetes, is being, used, globally, This kind of digital twins are also, we have found, this is another very good picture which you can see. All these parameters are being, captured either by pathology test or by, online, these sensors, which they apply to your body. At least, as per their recommendation, I interacted once, 1 or 2 times with their, team. One has to wear for, in a 24 hours, at least for 10 to 12 hours, And during night time, you can remove those sensors, so that they want to have a very correct picture about the parameters, which they like to monitor. And then, the system will analyze on the back end, and give the recommendations, as I said, about your diet, about medicine, our lifestyle, etc. And they have seen the very good, this mechanism of, knowing the behavior and, knowing the biology of a person is being analyzed by back-end AI system, and it gives them the remedy. As per their statistics, a majority of cases, has found a great improvement in controlling the diabetes 2 basically. So please go through this. So I thought, with this example, I should give you a feel about the digital twin, how it is being applied in case of our health also. I'm not explaining all these slides. You can take some time to go through them. If you have any query, you can also go to their site, twinhealth.com. I think in our deck, it is there. Now coming back to the conceptual framework, which I like to explain again with the help of some technical conceptual framework. So as you are seeing in this slide, there is one basic requirement for setting up the digital twin, especially in the manufacturing, IT/OT communication. See, we have one side the IT systems, which IT system also include AI systems, analytic systems, and your data bank, and data systems, And the other side we have OT systems. OT systems are basically the systems, which are attached, which are attached with the devices in the plant area, in the field area. So sometimes these are DCS systems, or they are PLC systems, they are SCADA systems. So one is that there should be a viable and seamless link between IT and OT system should be established. So this is a fundamental requirement of setting up the digital twin. So you can see here, this link, where you can go through. If you like to have more detail about that, there is a research paper available. So you see here, this is a pictorial depiction of this concept of OT and IT integration. So one side, we are seeing here the OT systems like sensors, PLC, which I have mentioned about that. Then through Edge Gateway, the data is being, or information is being, sent, to the IT system, and it's being done, here processing. And if there any feedback loop is required, it send the feedback loop, which I explain you for monitoring or for taking some action. So this is sort of, first requirement of setting up the cyber digital twin, which is a cyber physical system, I'll say, is that we have to set right. We have to set right our OT and IT system integration. The second step is digital twin is setting up the digital twin is a cyber physical production system. Set up the cyber physical production system, which include the physical cleaning of machine external entities. So digital twin doesn't work in the isolation. It has to also interface with the rest of the systems as well as. So for that also there is a schema which you are seeing on the screen right now. So very important aspect of this is that the digital master. We have to set up the digital masters which have data specifications or data metadata of the processes. All the safety functions, and other side, the digital shadow. So these two concepts one should understand, and third is that digital services. So digital shadow is basically this computer system should understand the physical physical, world, physical world, how it is behaving, how it is acting. So this is called, in our technical language or terminology, digital shadow. And digital services, what kind of services we are expected to deliver, whether these are require AI services or IoT services kind of thing. So once we start developing a digital twin, we have to work in these kind of areas. These are quite complicated areas, I will say, but there is no short path. If somebody wants to develop their digital twin and customize digital twin for their own requirement. So I have shown here these functions in a very, I will say this picture is of 10,000 feet kind of picture of those concepts. You will see here one side is a digital masters which consists of the item ID, CAD, bill of material, etc., the cost, etc., digital shadow, how the machine is functioning, like sensors data, historical data, and then what kind of digital services we like to obtain from digital twin. And then external system, if we have to get the information from the external systems like plant layout, cloud data, etc. So this kind of schema we have to develop. Then I am going to discuss this a little in detail. You are seeing over here an example of a physical pump, left hand side. A physical pump is there on the left hand side, which for which we like to develop a digital system, giving the services to the this digital physical pump. Sometime we like to monitor the real time basis. We want to track the temperature, pressure, etc. If there is an anomaly in the pump, we want to also fix the anomaly remotely. So it is not possible, for a suppose we have a large number of pumps. Sometimes we have thousands of pumps. It's not possible to have technicians manually watching and monitoring each and every pump. So here digital twin kind of systems are very useful. We'll see in a minute's time how it can be governed. In this slide, I am showing some of the use cases of digital twin, which has been curated or which has been identified from the studies World Economic Forum has done of global lighthouses, which we discuss in the third week itself. So digital twins are being used for the use cases are like that, flexible production, customer system, product design validation, predictive maintenance, and sustainability simulation. So I like to take this case of customer system and we will discuss in detail about that. This is the first use cases and how it looked like that. Now I'll come on the customer system. If you see the in customer system, one side there is a customer, customer site is there. Means you are providing service to a customer, customer plant, customer site. Certain services are expected to be provided. And you have a company office which is getting the data, and here is the digital twin or there is a digital system. Companies like Schneider Electric or Siemens and Royal Philips, there are many companies that set up the digital twin for customer services. Let us see one example. So digital twin for customer service experience here. This is a what kind of twin customer asset you are having. Install equipment at customer sites. These kind of equipments are there. Environmental usage, context, and contact. This is a contact. Now, how we deliver, predict failures, prevent customer downtime, prevent equipment downtime, optimize setting for energy, cost, and quality. Customer service enable remote monitoring, predictive maintenance. So these kind of expectations are there from digital twin, and we want to use this digital twin for not one or two customers. It should be customizable for any number of customers, for any kind of equipment, etc. So that is here the differentiating factor is the data. So what kind of data digital twin is having? Next is that proactive customer support for installed pump feet. How we'll provide the proactive customer support with the help of digital twin for an installed pump fleet. This slide explain in detail about that. The OEM has thousands of pumps across customer plants and worldwide. Customer panic, expected failures, high energy use, inconsistent service quality. This was the problems, and this is a problem statement, and how the twin help customer continuously calculate health index, cavitation risk and efficiency, simulate what if scenario, load, fluid property, speed. This is a part of the digital twin action domain, I will call it. And then set up the feedback loop, so that if any anomaly is there, it can be fixed. Now autonomous systems are also start coming in market, no, but if we don't consider autonomous system, the technician who is manning this digital twin, once he know that no so and so pump or so and so equipment is the problem, it requires some repair, or it requires some action, no, they will direct the action sitting remotely. That is what the customer experience can be expected here. What the action has been taken, customer will get the reflection of that on the dashboard. So this kind of scenarios are very common nowadays in digital twin. They are not only applicable for manufacturing. Digital twins are getting popularity, not only getting popularity even in the finance sector, marketing and sales functions, education sector. So this has become also a pervasive technology which is a and it is not an independent technology. It is based on the convergence of use of multiple other technologies, and the key technologies which is enabler for the digital twins are as follows: IoT, AI, edge computing, cloud computing, etc. So with this, what are the benefit of digital twin to OEMs? There are multiple benefits. In this scenario, I have captured few benefits like higher asset availability, product quality improvement, lower service cost per unit with the help of digital twin. Since manual intervention is not required, the downtime is being managed remotely, the cost will come down, the cost of maintenance will come down. And we can have a compliance structure also, KPIs, with the help of KPIs and regulatory reporting, the compliance can also be enforced by digital twin computer system easily. So with this, I like to now conclude this discussion showing whatever we discussed in this slide, that how this data flow and that action, one side is the data which is coming out from the customer side and then is being processed or is being captured and processed by digital twin. This is a third party system, and then action is being taken through a feedback loop by the company office, because the technicians they get the instruction or they get the decision or analysis from the digital twin, and then their engineers if they are not authorized this company, they will take the action accordingly and they fix the problem. So with this there are few examples which I have also included in this deck. Like digital twins are commonly used in aircraft industry, they are commonly used in the ship industry as well as because these are all very mission critical, very expensive assets, and they need on real-time basis monitoring of the performance and each and every part, each and every their equipment, and components, and here digital twin kind of approach is a very successful, very handy approach, in this industry as well as. I have also included some of the case studies or some of the examples from the industry, like Siemens, or this is example from Siemens, this is another example from Schneider. I like that the learners should study these examples their own. I have included here the URLs, and you will find that once you go in detail of this subject, that how good and how useful the subject is to understand that how Industry 4.0 and now Industry 5.0 are taking advantage of these kind of technologies. There are few papers also I have included, the reference papers. But as I said, this is the video which is on the Twin Health. You can click on this video, you can click on this site. This is usatwinhealth.com, and their Indian site is twinhealth.in. You can understand more about that application, Twin Health application, listening this video. Cambridge University also has quite a few very good document which I have shared the link of these documents over here. You can go through. This is another video which I have found very useful. You like to go through to understand that how in the smart grid, in the power system, digital twins are doing the useful work. Thanks you very much. I am sure that you would have appreciated these kind of inputs to understand the concept of digital twin. But the actual use, this is quite complicated system, complicated technology. But we will be further dwelling in this subject when we discuss the smart manufacturing. Thank you very much.